Our last section before test 1 is talking about inverse functions. If I have two functions, f of x and g of x, and I perform the composition f of g of x, and that is equal to x, and I perform the composition g of f of x and get x, I can then say that g is the inverse function of f. So the formal definition of an inverse function is it's a function that when I compose it with the original function in both directions, I get x. So another way to write this is f of g of x is equal to x, and g of f of x has to be equal to x. If this is true, then I can call g the inverse function of f. And the way we denote that is the inverse function of f, I'm going to write g of x is equal to the inverse function of f. Notice that this is not an exponent. When I write it like this, that says the inverse function of f. If I were to write something like this, f of x to the negative 1, that says to take the reciprocal of f of x. These two notations are not the same. So pay particular attention to where the negative 1 goes. Okay, this one means it's an inverse function, and this one means, hey, I want to do the reciprocal operation on the function. So I can replace g of x with f inverse of x. Then these two functions will write that f of f inverse of x is equal to x, and f inverse of f of x is equal to x. But this is saying that whatever number I put in for x in this composition or this composition, I'm going to get that same number out. And in Algebra 2, we informally said that if a function and its inverse perform consecutively, cancel each other out to give us back our original function. So this is the formal definition, and the informal definition is a function and its inverse perform consecutively, cancel each other out.